Hello guys, today let us discuss an important topic which is useful almost in every chapter, that is graphical transformations. What is graphical transformations is all about. Graphical transformations means when we given a graph of y equal to f of x, how to draw or how to transform this y equal to f of x to y equal to f of x plus some a and y equal to f of x minus a and some transformations, right? Yeah, these are the topics that will be covered today. That is how to draw these graphs or how to transform these graphs by knowing the graph y equal to f of x, right? These are the graphs we will discuss today, or these are the transformations we will discuss today, and how to deal with these transformations. Let us see. Okay, now let us consider y equal to f of x equal to some x plus 1. Now let us draw the graph of y equal to f of x plus a. Let us consider a equal to some 2. Now let us draw the graph of y equal to x plus f of x plus a, that is equal to x plus 1 plus 2. Okay, that is y equal to x plus 3. So now let us assume we know the graph of y equal to x plus 1. Now let us first draw the graph of y equal to f of x, that is x plus 1. This is y axis, this is x axis, right? Now let us consider, now this is the origin. Now y equal to f of x equal to y equal, that is equal to x plus 1. At x equal to 0, that will be 1, and when x equal to minus 1, that will be 0. Then the graph will be like I think it will be like this, joining its 0 comma 1, and it is minus 1 comma 0. This is the line y equal to x plus 1. Now when we know the graph of y equal to f of x, and when we want to draw the graph of f of x plus a, we have to transform the graph. We have to transform the graph through y-axis. Through y-axis, a units in the direction of positive y-axis. Let us see. We know the graph of y equal to f of x, and we want to draw the graph of y equal to f of x plus a, that is, so if we know the graph of y equal to f of x and we want to draw the graph of y equal to f of x plus a, we should transform the equation, the graph through y-axis, a units towards positive y-axis. I think you got my point. Now let us see this example. Now we have to draw y equal to x plus 1 plus 2. Now let us transform this graph a units upward, that is 2 units upward. Okay, when we transform this graph by 2 units, towards positive y-axis, it will the y-intercept will go to 0, 3. So the now y-intercept now will be 3 units, that will be at 0, 3. At the same time, when we transform this line 2 units towards positive y-axis, this x-intercept will be at minus 3, 0, right? So it will be at minus 3, 0. And the line will be like this. This is what y equal to x plus 1 plus 2. You can verify this graph with y equal to x plus 3, and the graph of y equal to x plus 3 is exactly the same. So that's what how to transform y equal to f of x to y equal to f of x plus a. Means we have to shift the graph a units towards y-axis to obtain y equal to f of x plus a, right? By solving some more examples, you can understand. We will solve examples in the last of the video. Now let us go to the second one, that is y equal to f of x minus a. Now let us see how to transform by knowing y equal to f of x to y equal to f of x minus a. Now let us see. Let us consider an example like y equal to f of x equal to modulus of x. We will solve this example, but beforehand let's see let's see what is the definition, like how to transform the statement. Like when we know y equal to f of x and we want to draw the graph of y equal to f of x minus a by knowing y equal to f of x, then we should transform the graph in the direction of negative x-axis a units towards negative x-axis. Now let us see an example and we can get a clarity. Now let us draw the graph of y equal to f of x equal to modulus of x. I think this is the graph and it is y-axis, x-axis, and this is the origin. This is the graph of y equal to modulus of x. Now I will consider a equal to 2, right? I will consider a equal to 2. Now I want to draw the graph of, this is y equal to modulus of x plus c. Okay, x plus c, and I think wrong. This is x plus c. Okay. Now when we want to draw the graph of y equal to modulus like f of x plus c, that is equal to f of x plus 2. Now we should we should transform the graph 2 units towards negative x-axis. Now let us see. This is what y equal to modulus of x. When we want to draw the graph of y equal to modulus of x plus 2, we should transform this graph 2 units towards negative x-axis. Then the the point where the V shape occurs will be minus 2 comma 0, right? So at minus 2 comma 0 there will be V shape, and this is what the graph of y equal to modulus of x plus 2. You can even check it when we transform this to minus 2 comma 0, origin to minus 2 comma 0, then it will be 0 comma 2, right? So even you can check. So now let us see how to draw the graph of y equal to modulus of f of x by knowing the graph of y equal to f of x. We can draw the graph of y equal to modulus of f of x by knowing y equal to f of x by taking the image of the graph y equal to f of x which is below the x-axis. Now let us consider an example like y equal to f of x equal to, let us consider x, y equal to x. So we know the graph of y equal to x, that is this is like passing through origin and symmetric in the opposite quadrants, right? So this is y-axis, x-axis, this is the graph of y equal to x. So now to draw the graph of y equal to modulus of f of x, that is y equal to modulus of f of x, that is mod x. To draw the graph of mod x by knowing the graph of y equal to x, we have to take the image of the part which is below x-axis by taking x-axis as mirror. I mean this is the graph of y equal to x. We have to take the image of the part which is below x-axis in x-axis. Image of the graph which is below x-axis in x-axis, I mean x-axis as mirror. So this will be y equal to modulus of x. You know, this is x-axis and this is y-axis, origin, and this is also origin. So this is what y equal to modulus of x we know already. So if we want to draw the graph of y equal to modulus of f of x by knowing the graph of y equal to f of x, we have to flip the part below x-axis by taking x-axis as mirror and draw like this. Okay, so that is how to draw the graph of y equal to modulus of f of x by knowing the graph of y equal to f of x, y equal to f of x. Now let us see how to draw the graph of f of modulus of x by knowing the graph of y equal to f of x. Now it is also similar. We have to take the image of the part which is the right side of y-axis by taking y-axis as mirror, and so let us discuss by taking an example so that we can understand in detail. Now let us consider an example y equal to f of x equal to x plus 1, right? And we want to draw the graph of y equal to f of modulus of x, that is modulus of x plus 1. So now let us first draw the graph of y equal to x plus 1. This is minus 1 comma 0, this is 0 comma 1, and this is the graph of, sorry, it's not nice, it is the graph of y equal to x plus 1, right? So in order to draw the graph of y equal to f of modulus of x, we have to consider the part which is only right side of y axis, that is 0 comma 1, and take the image of that part in y axis. This is origin, this is x axis, x dash, like this. So this is the graph of y equal to modulus of x plus 1. You can check when at x equal to 0, y equal to 1, and at x equal to x equal to 1 it is 2, and x equal to minus 1 also it is 2, and the graph is same, and this is verified, right? So now let us see how to draw the graph of y equal to f of minus x by knowing the graph of y equal to f of x. It is just the how to transform this is just to flip the graph over y axis, right? Flip the graph over y axis. Just consider. So now let us see an example, right? Is y equal to x plus 1. Now let us draw the graph of y equal to f of minus 6, that is minus 6 plus 1. Now we have drawn just now so many times the graph of y equal to x plus 1, that is minus 1 comma 0, 0 comma 1, this is y axis and this is x axis, right? And to draw the graph of y equal to f of minus x, what I said is just flip over y axis, right? Just take the image over y axis. That will be like this. It's like 0, 0 comma 1, it's 1 comma 0, and like y equal to minus x plus 1. You can check it, you can verify it, and it will be same. Now in a similar way we can draw the graph of y equal to minus f of x by knowing the graph of y equal to f of x. It is just flip over x axis. Let us consider the same example, y equal to x plus 1. Now we have to draw y equal to minus f of x, that equal to minus of x plus 1, that is minus x minus 1. To draw this graph, it is just flip over x axis. So just flip it over x axis, it will be like this, right? So this is minus 1 comma 0, so 0 comma minus 1, this is y dash y x dash x. So this is what y equal to minus f of x, that is minus x minus 1. You can check the graph of y equal to minus x minus 1, and it will be exactly the same, right? there is one more I forgot, that is one more extra, that is modulus of y equal to f of x. Now let us discuss that transformation. So how to draw the graph of modulus of y equal to f of x when we know the graph of y equal to f of x. It is it is flipping the part which is above x-axis and neglecting the part which is below y-axis, that is below x-axis, sorry. Now let us see an example. We know the graph of y equal to sin x and we want to draw the graph of modulus of y equal to sin x, right? So now we can draw it by first of all, let us draw y equal to sin x. It's a trigonometric function. 0 pi by 2, it's pi, and 3 pi by 2, 2 pi, like this one. So and it is minus pi by 2 minus pi and so on, and it's origin, it's 1, it's minus 1, it oscillates between minus 1 and 1, I think we know. Yeah, x does. Now to draw the graph of mod y equal to sin x, just neglect the part which is below x-axis. This part, just neglect it and take the images of the part which is above x-axis. Now let's draw. And neglect the part. I think it's 0, it's pi, it's 2 pi, and it's 3 pi. The similar way, just neglect this part. This is minus pi, minus 2 pi, and so on to this one. So this is what the graph of mod y equal to sin x. By knowing the graph of y equal to sin x, this is how we can draw the graph of mod y equal to sin x. Let us see some more examples of the last. Now let us go to the end of the transformation. So now let us discuss the end of the transformation, that is drawing the graph of y equal to f of ax by knowing the graph of y equal to f of x, right? So to draw the graph of y equal to f of ax by knowing the graph of y equal to f of x, we have to compress the graph of y equal to f of x a times, or make an horizontal stretch of 1 by a times. I think you got my point. Drawing the graph of y equal to f of x by knowing the graph of y equal to f of ax by knowing the graph of y equal to f of x is making a horizontal stretch of 1 by a times along y x-axis. I mean horizontal stretch means x-axis, stretch over x-axis. Let us consider an example to discuss in detail. Now let us consider y equal to f of x equal to sin x and a equal to 2. Now y equal to f of ax equal to sin 2x. Now let us draw the graph of y equal to sin 2x by knowing the graph of y equal to sin x. Now y equal to f of x equal to sin x. Now let us draw is we start the graph. It is it's 3 pi by 2, 2 pi, so on. It's origin and it's minus pi and so on. So now by knowing the graph of y equal to sin x, how to draw the graph of y equal to sin 2x? Just make an horizontal stretch of 1 by 8 times, that is horizontal stretch of 1 by 2 times, that is compression by 2 times, I think. It's pi by 4. When we make in compression, pi becomes pi by 2, so it will be like this, and this will be 1. This is what the graph becomes. This is pi and this is no, it's pi by 2 and it's pi. I think it's okay. Yeah, so this is minus pi by 4, minus pi by 2 and so on. So this is what you want to convey is just compressing the graph by 2 times. I think you got my point. Now let us go to the another transformation, that is drawing the graph of y equal to a into f of x by knowing the graph of y equal to f of x, right? So how we can draw? This is simple. We can draw the graph of y equal to a into f of x by knowing the graph of y equal to f of x by making a vertical stretch of 8 times. By making a vertical stretch of 8 times. So let us consider an example to discuss in detail and get a clarity. Let us take the same example, y equal to sin x as f of x, and when we want to know the draw the graph of y equal to 2 sin x, we have to make a vertical stretch, right? So the graph of y equal to sin x is here, and to draw the graph of y equal to 2 sin x, just we have to make a vertical stretch to this graph. We have to vertical stretch by 2 times, so the 1 becomes 2. Here I think it's 1, it should become 2. So now it is like this. It's pi by 2, it's pi, it's 2, like this, minus pi by 2, minus 2, and so on. You can check it. Minus pi, minus pi by 2, and so on. This is vertical stretch by 8 times, right? So this, I think you got my point, and you can check that at x equal to pi by 2, when you substitute, it is 2 into sin pi by 2, that is 2 into 1, that is 2, is 2 into minus pi by 2, minus 1, sin, 2 into sin of minus pi by 2, minus 1, 2 into minus 1, that is minus 2, minus pi by 2, and the graph is as it is. I think you got the points in this topic, that is graphical transformations. Doing some more practice and practicing some more examples on this gives us a clarity on this topic, and can get a comment on this topic. So practice some more problems on this topic so that you can get a comment. So if you like the video, like, share and subscribe. That's it for today. Thank you. So the graph of y equal to modulus of x plus 2 is exactly what it is. So to get the graph of y equal to f of x plus a, by knowing the graph of y equal to f of x, we have to shift the graph towards negative x-axis a units towards negative x-axis. But when we want to draw the graph of y equal to f of x plus a, we should shift towards positive y-axis a units. There that is positive y-axis, here it is negative x-axis. I think you got it.